Hello, it is Mrs. Applegarth. We are talking through section 7 for similarities in right triangle. The first piece of information that I want to give you guys is the definition of an altitude in a triangle. The altitude goes from the vertex, or the little pointy piece at the top like this, to the base of the triangle. It hits at a 90-degree angle. So like this guy right here is going to be the altitude. So that's important because we're going to call him out by name, and if you don't know what an altitude is, it might be really confusing. So theorem 7.3, similar right triangles theorem. The altitude to the hypotenuse of a right triangle divides the triangle into two triangles. So from here, A, B, C, we drop that altitude and we get two triangles, one on the left and one on the right, that are similar to the original triangle and to each other. So please draw this picture. It will make way more sense than trying to noodle out the words. So with that said, so you think about it like this. So when I redraw everything, I draw it with the 90-degree angles on the top, the kind of thicker angle on the left, and then the little guy on the right. So if you look, these are all positioned the same way. So this guy on the right got flipped over and upside down, so that B ends up on this side and C on this side. So you guys, orienting your triangles is going to be important. Then we take our similarity statements, and this you definitely need to write down as well. Triangle ABC, the big guy, is similar to triangle ACD. Triangle ABC, which is also the big guy, is similar to triangle CBD. And triangle ACD, which is the little guy, is similar to the medium-sized triangle CBD. Okay, we're going to spend some time trying to match up our triangles so that they look like this guy here. And in fact, I will, I think I can, let's change and widen this out a little bit. Okay, so what similarity statement can you write relating the three triangles in the diagram? So firstly, I wanted this big triangle to be flipped over so it's oriented the same as this triangle here. And when we do that, we see that Q is in the same position as A, P is in the same position as C, B is in the same position as R, and D is in the same position as S. So here I'm going to make myself a little key. So A is with Q, B is with R, C is with P, and D is with S. So that way when I put my similarity statements together, wherever there's an A, I'm going to put a Q. Wherever there's a B, I'm going to put an R. Wherever there's a C, I'm going to put a P. And wherever there's a D, I'm going to put an S. So triangle QRP is similar. So instead of ABC, it's QRP. Is similar to triangle. It used to be ACD up here. ACD. But now we have QPS. Boop. Okay, we're going to do that again. Triangle QRP is similar to triangle QRP. Oh, I erased. Hold on, no, it's not right. Is similar to triangle QRP, CBD. C, which is P, B, which is R, and then D, which is S. So I'm just matching, using like this as a decoder ring. And triangle QPS is similar. So it used to be ACD, now it's QPS. is similar to triangle, used to be CBD, CBD, PRS. Okay, so you guys, we're just matching it up so that we're using these similarity statements. Okay, the geometric mean for any two positive numbers a and b, the geometric mean is the positive number x such that a over x is equal to x over b. And essentially what we're going to do is we're going to solve for x. So when they ask us what is the geometric mean of 4 and 18, so we're going to put 4 where the a goes and 18 where the b goes. And so we get 4 times 18 equals x squared. So 4 times 18 is 72. Look at my wonky 72. That's crazy. And then x times x is x squared. So we take the square root. Sorry. So in order to get rid of an x squared, we take the square root of both sides. So what we're going to do is we're going to look at the radical form of square root of 72. Square root of 72 is not a perfect square, but there is a perfect square that lives inside of 72. So if I'm listing the factors of 72, I have like 1 times 72, 2 times 36, 3 times 24, 4 times 18, 9 times 8, 72 divided by 6, 6 times 12, okay. And then we look at each one of the factors and we go, are there any perfect squares that live inside of 72? That's how I refer to it. So just for fun, let's think about all of our perfect squares. What's 1 squared? What is 2 squared? What is 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? 12 squared? 13 squared? 14 squared? And 15 squared. Okay, so these are some perfect squares, and we can use these to go, okay, do any of these have a perfect square? Well, I can see that 9, 4, and 36 are all perfect squares. Which one is the biggest? So just so that you can see where I'm tracking. 9 is a perfect square, 4 is a perfect square, and 36 is a perfect square. We are going to pick this one because it has the largest perfect square chilling inside that. So instead of 72, I'm going to go 2 times 36. And I'm going to go ahead and take the square root of 36 and put it out front. What's the square root of 36? 6. And then the 2 stays underneath because it's not perfect. Anything that's not perfect has to stay inside. It's like the imperfect jail. So you only go there if you're imperfect. If you're perfect, you can go ahead and get out. Okay, we're going to look, we're going to put together some proportions based on the information that we have with, in terms of these are right triangles, similar right triangles. So please draw this. So we've got a nice right triangle here. We've got an altitude that cuts it, and it creates 2 similar triangles. So we have the altitude of 4. We have the little piece of the hypotenuse 2, and the bigger piece of the hypotenuse 8. So we can make a ratio based on these three different numbers. So if you have an altitude and the measurements of the hypotenuse, you can put together 2/4 proportion equal to 4/8. So the ratio of the little piece of, I think of it like the small side over the medium side is equal to the small side of the medium triangle over the medium side of the medium triangle. So it's like small side over medium side, small side over medium side. So we can put together a little statement. We are going to do this in our example problems and put together proportions to solve. Okay, the altitude to the hypotenuse of a right triangle separates the hypotenuse. So here's the other version of it. So here is our big triangle. We have our altitude, and if you look, we have the outside leg, and we have our hypotenuse pieces. So the ratio goes the hypotenuse over the outside leg is equal to this outside leg over the piece of the hypotenuse. So we are going to match up for some of the triangles. We're going to decide, is it this one where we have the inside altitude, or is it this one when we have the outside leg? And whichever one it is, we're going to make two proportions similar to the way these examples have been made. Okay, so let's go ahead and see how we are going to do that. And then when you're in class, I'll show you the way I do it, and then I'll have to remember any of that. Okay, here is a triangle, and we're going to use the theorem 7.3 to find the values of x and y. So we are going to go ahead and have our big triangle. X is on the outside leg, so the one that where we're going to use the x is going to be the second one, and then the y is the altitude. So I'm going to go ahead and go back here and take a picture. So we can get our okay. So the situation with y is where we have y is this 4. So everywhere there was a 4 here is going to be a y because that's the altitude. So instead of a 4, it's going to be a y. Okay, and then the piece, so here's the altitude, here's the hypotenuse. Here is this hypotenuse. So one of these guys is going to be, so in here, here's our altitude. This piece where the 2 happens, I'm going to put 4. And then the piece where the 8 happens, I'm going to put 5. Okay, then I cross multiply and I get y squared equals 20. Now we have to say what perfect square lives inside of 20. Well, 20 is like 2 times 10, 4 times 5. 4 is a perfect square. We're going to go ahead and take the square root of 4 and leave the 5 inside. Yay, now we have y. Okay, we're going to dump this. Actually, yeah, we're going to dump that. We're going to go back and pull the second example. Does not like when I do that. Pull the second example. And then put together this one. So if you look, here is our big triangle. The outside guy is 2. So anywhere the 2 happens, we're going to put an X because that is the outside leg. And then in this case, the whole hypotenuse is 4. So the whole hypotenuse for us is 9 because it's 4 plus 5. And then this little snippet here, which is the shorter piece of this leg, is 4. Okay, so then we cross multiply and we get x squared equals 36. We take the square root of both sides so we can find x, and then we get x is equal to 6. Okay, I'm going to keep this up here because I'm going to use him for our example 4. Using the corollaries, find the value of x. We have to use quadratic equations. So we're preparing for robotics competition using the setup shown here. Points A, B, and C are located so that AB is 20 inches. AB is perpendicular to BC. Point D is located on AC so that BD is perpendicular to AC, and DC is equal to 9 inches. You program the robot to move from A to D and to pick up the plastic bottle at D. How far does the robot travel from A to D? Okay, so it is this scenario here. We have information about the outside leg and the hypotenuse. We don't have any altitude information, so we're not going to use that other one. Okay, so where we had the outside leg, which is the 20, we are going to put it where the 2 is here. Okay, and then the hypotenuse is going to be 4. Our hypotenuse is 9 and x combined together, so that's 9 plus x. And then our little piece, but if you look orientation-wise, it's this piece here, and we don't know how little or big it is. It's just x. Okay, so we're going to cross multiply, and we get 9 times x, and plus x squared equals 20 times 20. To get everything on one side, when you have a quadratic like this, you need everything on one side of the equation. So we have to subtract 400. So we get, let's sort this out a little bit better. So we put the x squared in front plus 9x minus 400. We want to factor this guy out. So which two numbers multiply to give you negative 400 and add to give you 9? It took me a minute to noodle this, but it is 16 and negative, or 25 and 16. So it's minus 16 plus 25. When you add those together, you'll get 9, and when you multiply them, you get negative 400. Okay, so the way to solve when you get to this spot is you say x minus 16 equals 0 and x plus 25 equals 0. Well, we know if we solve this, minus 25 from both sides, x is equal to negative 25. Cannot have a negative distance. So when we add 16 to both sides, we get x equals 16, and that is the answer to this question. Here is the homework. Make sure you show all your work, and have a great day.